In section 8.1, we are going to review squares and square roots. So if you remember a square of a number, it is the result of multiplying that number times itself. So here, if we have 5 squared, that is really 5 times 5, which gives us 25. So if it's asking for the square of 7, that is really 7 squared, which equals 7 times 7, which gives us 49. And then 3 squared, we know that is 3 times 3, which gives us 9. 3 times 3. The square root of a number is the number that when squared gives n back as a product. So if we think about the square root of 100, we want to find out what number squared gives us 100. So if you know this one off the top of your head, you know that 10 times 10 gives us 100. So that means the square root of 100 must be 10. Again, we can check that. 10 times 10 gives us 100. Okay, 64. We want to figure out what number times itself is going to give us 64. And we know that 8 times 8 is 64, so the square root of 64 is 8. And for the square root of 1, we know that 1 times 1 is going to give us 1, so square root of 1 is just 1. And then the square root of 25, so if we write it square root of 25, we know that 5 times 5 gives us 25, so the square root of 25 must be 5. And you can type this into your calculator. There is the little square root button on your calculator where you can type in these numbers and you'll get the same answers, but it's important to know what that square root symbol means. So now we have some word problems. Our first one says, what is the area of a square with side length s? Okay, so we know if we have a square, it's not a very good square, let's try it again. We have a square and the side length is 11. To find the area of that square, we do length times width. So here we have 11 times 11, or 11 squared. And when we type that in, 11 times 11, or 11 squared, into our calculator, we get 121. Now, if the area of a square is 36 square units, we want to know what the side length is. So if our whole area of the square is 36, we want to find out what our side lengths are. So what times what gives us 36? And we need to take the square root because those x's need to be the same. And if we do that, you can either type it in, or if you know, 6 times 6 gives us 36. So square root of 36 is 6. Okay, B, if the area is 33 square units, so again we need to do our square root of 33 to figure out what those sides are going to be. So this 33 squared is going to equal our side length. And when you type that into your calculator, you get the side is about 5.74. Okay. Numbers that you can take the square root of are called perfect squares. So a perfect square is something where we're not going to get a decimal, like 4. 4, you take the square root, and you know that 2 times 2 gives you 4, so our answer here is 2. It's a perfect square, no decimals. 36 is another perfect square, since 6 times 6 gives us 36. Our answer is 6. 33 is not a perfect square because if you looked above, when we took the square root of 33, we got a decimal. We got 5.7. So 33 is not a perfect square. When we get an imperfect square and we're trying to find the answer, we can do it two ways. And number one is with a calculator. You can type square root of 63 into your calculator and you should get 7.9. And if you can't find the square root button, make sure you raise your hand and ask me so that I can show you where it is because you're going to need it for your homework. Okay, square root of 80, you type that in, you get 8.9. And square root of 2, you type that in, you get 1.4. The second way you can find the imperfect square without a calculator is to make a factor tree. And we are going to look at a few examples of these below. So if we look at example 1, we have the square root of 9. Square root of 9 is a perfect square, so we don't have to use a factor tree for this one. We know that 3 times 3 gives us 9, so our answer for number 1 is 3. Number 2 is an example of an imperfect square, and this is where we're going to use a factor tree. So if we have 24, we can divide that up into 12 and 2. 12 times 2 gives us 24. That 2 is as small as we can get on this side because the only way we could break that 2 down would be into a 2 and a 1, and we still have a 2 there. So that 2 is the smallest we can get on this side. But we can break this 12 down again into a 2 and a 6. So again, we reach our limit here, 2 as small as we can go, but we can keep breaking the 6 down. We have 6 is equal to 3 times 2. Okay, and so again here, 2 times 1, smallest we can go, 3 times 1, smallest we can go. So we broke this 24 down into 4 different numbers. We have 2 times 3 times 2 times 2. That's going to give us 24 still, so we are going to rewrite our square root with using those numbers. So square root of 24 is equal to the square root of 2 times 3 times 2 times 2. We're just breaking that 24 up into smaller numbers. Okay, so once we reach this step, if we look back up here at our steps, we made a factor tree for the radical. And the second step says that a pair of like factors underneath the radical equals one regular number outside the radical. So if you notice here, we have a pair of 2's right here. So this is saying that pair of 2's is like putting 1 2 on the outside right here. So if we change those two 2's to 1 2 on the outside, we still have square root of 2 times 3. And that is all the pairs of numbers we have under that radical. So we can either leave it like this, square root of 2 times the square root of 2 times 3, or we can multiply those numbers under our square root again, and we get 2 times the square root of 6. The other way we can do that is to type square root of 24 into our calculator, and it is going to give us 4.9. But sometimes we don't want our answers in decimal form because our decimal is rounded. This is not the exact amount under that square root, so a lot of times this form will become more useful. So that's what we're going to practice on these next few. So if we look at square root of 72, I know that I can break up my 72 over here. So if I have 72, divide that by 2 and I get 36. Then this is my final number here, 36 divided by 2 again. 36 is equal to 2 times 18. Final number on this side, 18 is equal to 2 times 9. And 9 is equal to 3 times 3. So these are my final numbers. I can rewrite my square root. 72 is equal to 2 times 2 times 2 times 3 times 3. So I can write all those under here. 2 times 2 times 2 times 3 times 3. Okay, so then wherever I have a pair, I can bring one of those outside of my square root. So I have a pair of 3's, so I can bring my 3 outside. And I have a pair of 2's, so I can bring a 2 outside. So now outside I have 3 times 2, and underneath I still have 1, 2. 3 times 2 on the outside gives me 6, and I still have square root of 2. So this is my answer. This is equal to the square root of 72. For the next one, 75, I can break that up into 5. I know I can divide that by 5. And that is going to give me 5 times 15 gives me 75. My 5 can't divide up anymore, so I'm going to have 15 also gives me 3 times 5. 3 times 5. 3 times 5 gives me 15. And again, I'm done. I can't break up that 3 or 5 any farther. So I rewrite my radical. I have square root of 75 equals 5 times 5 times 3. I've got one pair of 5's underneath, so I can take 1 out. Sorry, there's a square root. And I still have 3 underneath. Okay, we've got 2 more. So I've got 12 under my square root here. So if I'm breaking up 12, I know 12 is 3 times 4. 4 is 2 times 2. So 12 is really equal to 3 times 2 times 2. So I can rewrite my radical. 3 times 2 times 2. I've got a pair of 2's, so I can take 1 out. And then I have 3 times 2 square root of 3 left. 3 times 2 is 6, and I have a square root of 3. That is my answer for number 5. Number 6, I'm breaking up 54. I know 54 is equal to 2 times 27. 27 is 9 times 3, and 9 is 3 times 3. So I have 2, 3, 3, and 3. So I still have my negative 8 out front. Under my square root, 54 is the same thing as 2 times 3 times 3 times 3. I've got a pair of 3's under here. So that pair of 3's becomes 1 3 when I bring it outside. And then I still have a 2 times 3 underneath. Now I have negative 8 times 3, which gives me negative 24. And then under that square root, I have 2 times 3, which gives me 6. So this is my answer for number 7. Sorry, 6. Number 7, we are breaking up 2,500. I know that this right here is 25 times 100. I can break 25 up into 5 times 5. Those are my final numbers on this side. I can break 100 into 10 times 10. Now I can keep breaking those 10s up, but if I have a pair of 10s right here, that means I can take that pair of 10s and bring 1 to the outside. So if I rewrite this as I have it now, I would have square root of 5 times 5 times 10 times 10. I have a pair of 5s, so that brings 1 5 to the outside, and a pair of 10s, so that brings 10 to the outside, and I have nothing left under my square root. So all I have left is 5 times 10, which gives me 50.